Today in honors chemistry, we're going to start talking about the general types of chemical reactions or chemical equations. I'll have two different videos. One will deal with synthesis and decomposition, and then the other one will deal with single displacement, double displacement, and combustion. So there are 5 general types of chemical reactions. And the first one that we're going to explore is called a combination reaction. It can also go by the name synthesis, composition, or addition. In this type of reaction, you will have 2 or more reactants. They can either be elements and or compounds. So it could be an element and compound, go together and make a single product. So you'll know it is a synthesis reaction if on the product side you only have one product. There's not two different products. A group 1A or group 2A metal may combine with a nonmetal to make a salt, so that's a possibility. Or 2 compounds can combine to form a single product. Usually, if your 2 compounds combine, it would either be a metal oxide plus carbon dioxide, and that will make a metallic carbonate. It could be a metal oxide and water, would yield a metal hydroxide. It could be a metal oxide and sulfur dioxide. That would yield a metallic sulfite. It could be a non-metallic oxide plus water, and that would yield an acid. And so we'll have some of these examples in the equations that we're going to do in a second. Okay. Make sure when you are doing any of these types of reactions to write the product that you look at the charges, unless it is a molecular compound. Okay, so our first reaction is a simple one. It is simply 2 elements, so all you can do is stick them together. Remember that I2 is written like this because it is one of your 7 diatomic. So if you have Li and I2 combined, you will simply put them together, Li, look at their charges, +1, -1, so we have written that correctly, and then you will balance. So you have 2 I2s here, so we know that we're going to put a 2 here. And since we have 2 LIs, we're going to put a 2 here. So that one is pretty simple. Okay, the next one, once again, we have 2 elements. Nitrogen, once again, is one of the 7. That's why it's written as N2. So we just simply stick them together. Always make sure you write your metal first. Okay, so Mg and N. You look at the charges. This is a 2+, 3-, so you crisscross. So this is going to be Mg. Didn't leave myself much room, did I? Mg3N2. And so we're to balance it, we will simply put a 3 in front of the Mg. Okay, now we have Mg and O. So O is one of your 7. So you simply will put them together and say MgO. This is a 2+, 2-, so it's written correctly. We have 2 oxygens here, so we're going to put a 2 here. Now we have 2 magnesiums, we're going to put a 2 here. Okay. Ag and O2 will go together to make AgO. Ag is a +1, O is a 2-, so you crisscross, so that would be Ag2O. Now you balance, you have 2 Ag, so you're going to put a 2 here. And you only have 1 oxygen, 2 here, so we're going to put a 2 here. Now that unbalanced our I'm having a hard time talking. Unbalanced our silver, so we have 2 times 2, so we're going to mark that out, and we're going to put a 4. Okay, let's do one compound, and then you can use these rules up here, put me on pause, and then finish it up, and then come back and check with me. Okay, so next you have water and sulfur trioxide. So here it tells you that you have a water and a non-metallic oxide, so you're going to get an acid, okay? So your acid would be H2SO4, okay? All right, so put me on pause and then come back and join, and let's see how you did. Alrighty, so hopefully, once again, you realize that you have water and you have a non-metallic oxide. In this instance, you're going to make sulfurous acid. So here you made sulfuric, here you're going to make here you make sulfuric acid, here you make sulfurous. Okay, on the next one, this is a metal oxide and carbon dioxide, so it tells you up here a metal oxide and carbon dioxide produces a metallic carbonate. Metallic just means there's a metal in the front of your carbonate, and so your metal is Ba, so it's BaCO3. Don't have to do anything to balance. One Ba, one carbon, 3 oxygens, 3 oxygens. Next, you have, once again, a metal oxide, but now you have a metal oxide and a sulfur dioxide. So you're going to make a metallic sulfite. So your metallic element is your calcium. Sulfite, if you'll remember from your polys, is SO3. So you put CaSO3. 2 plus, 2 minus. You have written that correctly. You have 1 calcium, 1 sulfur, 3 oxygens, 3 oxygens. Okay, next up, you have a metal oxide and water. So it tells you right here, metal oxides plus water make metal hydroxide. So your metal hydroxide would be NaOH. You have 2 NAs here, so you put a 2 here. You have 2 hydrogens. When you put a coefficient of 2, that gives you 2 hydrogens. You have 2 oxygens on the product side. You have 2 oxygens on the reactant. Okay, next up, you have a metal oxide and water. Once again, so a metal oxide and water will make a metal hydroxide. So your metal hydroxide would be CaOH2. So Ca is a 2 plus, OH is a 1 minus, so you're going to have 2 of the OHs, so remember you put it in parentheses. So everything in the parentheses gets multiplied by the subscript on the outside. So you have 1 calcium, 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. Okay, so that is it for combination reactions. Okay, the opposite of a combination reaction is a decomposition reaction. So if you'll recall, if it is a combination or synthesis, you'll only have one product. You'll have 2 or more reactants making one product. With a decomposition reaction, you'll only have one reactant. It's going to be a compound, and it's going to break down into 2 or more products, okay? So a single compound will break down into 2 or more elements and or compounds. Get this out of the way. It is the opposite of synthesis. Often it will require energy in the form of heat, light, electricity, or a catalyst to get the reaction started. If it is a compound that includes a polyatomic ion, it will often be one of these. So some of these are the very opposite of what we did on the page before. So if it's a metal carbonate, it's going to break down to a metal oxide and CO2. If it's a metal hydroxide, it will break down to a metal oxide and water, which will be in the gaseous form. Metal chlorates will break down to metal chlorides plus oxygen gas. Metal nitrates will break down to metal nitrites and oxygen gas. Metal sulfites will break down to a metallic oxide and sulfur dioxide, SO2. Hydrogen peroxide will break down into water and O2 gas. So hydrogen peroxide, when you buy it in the store, it's in a dark bottle because light will cause it to break down. So it's got to be in a dark bottle to prevent light from reaching it. And then oxyacids will break down. So remember, an oxyacid is hydrogen on the combined with the polyatomic ion. They will break down to non-metal oxides and water. Okay, so we have several problems here to work. So we have sodium nitrate. So it tells you here that metal nitrates break down to metal nitrites and oxygen. So our metal is sodium. So our metal nitrite would be NaNO2 and oxygen gas. So I'm going to put an arrow up for gas, so you can put G in parentheses. Plus 1, minus 1, so we have written that correctly. We have 1 sodium, 1 nitrogen, 1 nitrogen. We have 4 oxygens, we have 3. So we're going to have to put a coefficient in front of NaNO3, so we're going to put a 2. So we start with your lower coefficient. Now that changes your sodiums and your nitrogen. So if we have 2 here, we're going to simply stick a 2 here. So now we have 2 sodiums, 2 nitrogens, 2 nitrogens. We have 2 times 2 is 4 plus 2 is 6 oxygens, and 2 times 3 is 6, so you are balanced. Okay, H2O, simple. All it can break down into is H2 and O2, hydrogen gas and oxygen gas. So you can put an arrow up on both of them or G after them. So we have 2 hydrogens. We have 1 oxygen, 2 oxygens, so we know we're going to put a 2 here. That changes our hydrogen, so we're simply going to put a 2 here. Okay, KClO3 is a metal chlorate, so metal chlorates break down to metal chlorides and oxygen gas. So your metal chloride would be KCl, because our chloride is just chlorine, and oxygen gas. Okay, we have 3 oxygens here, 2 here, so we're going to have to get them both to the same, so we're going to put a 3 here, and we're going to put a 2 here. That makes our oxygens balance. However, now we have 2 Ks and 2 Cls, so it's simple enough. We can just put a 2 there. Okay, so if you want to put me on pause and then you can join back, remember you've got these up here to help guide you. Okay, so hydrogen peroxide, we said, breaks down to water and O2 gas, okay? And you've got 2 hydrogens, 2 oxygens. You've got 3 oxygens here, so we're going to have to put a 2 here, and we'll put a 2 here, and now your hydrogens are balanced, your oxygens are balanced. Okay, this is a metal carbonate. Metal carbonates break down to metal oxides, so this is simply going to break down to ZNO plus CO2 gas. 1 ZN, 3 oxygens, 3 oxygens. Mercury 1 oxide, I believe, will break down into the 2 elements that make it up, Hg and O2. Okay, so we know we're going to have to put a 2 here to balance our oxygens and a 2 here. Okay, this is one of your oxyacids, and this is an oxyacid. Okay, so here we're going to break it down into water and a metal oxide, so we know we're going to have water, and so your metal oxide would be you're going to break it down to a non-metal oxide. So your non-metal oxide is going to be CO2. Okay. You want carbon here to have the same oxidation number it had here. So if this is a +1 here, then this is going to be a +2. This is a -2, so this is a -6. So we'll have to make this a 4 here. Okay. So carbon's still going to have the same oxidation number here, so it's got to be a 4. So you'll write it like that. So you'll have to have 2 oxygens. Okay, the same thing on sulfurous acid. It's going to break down into a non-metallic oxide and water. So we already know we're going to have water, and then your non-metallic oxide would be SO2. And I don't think you have to do anything to balance. All right? Okay, so that is it for this section. So this goes with your homework set 2 that is, I think, titled Synthesis and Decomposition Reactions.